This is Dr. Sendil Kumar Natarajan. I'm working as assistant professor in NED. I'm working in the area of solar energy. So now this is the one of the applications where you can minimize the cost of the solar power plant, because some of the times that is manufacturing cost and then assembling cost, all those things will be involved to increase the cost per watt actually. So in these sessions, I'm going to describe where are the possible areas in the energy sector where you can effectively use the robotics so that we can minimize the cost, the energy productions that we will see. So almost we are working in the energy, especially solar thermal and solar PV, in the past 15 to 17 years actually. With this experience, I will share the few slides. Yeah, you know that the renewable energy, in the broad classification, renewable energy. So in this renewable energy, we have the solar energy, wind energy, hydro energy, and biomass energy. All those things are there. Tidal energy, everything. Among this, why we have to use robotics in the energy sector? In what way it will be useful, and how to minimize all these things? That is the things. It is, you can say that if you use this in the sections of manufacturing, assembling, and installation, and inspections, and maintenance of all the renewable energy sources, we can use the robotics actually. That is the things. So where you can use, we will see in which particular area of the energy sector we will see that. So by using this, what is going to happen actually? So now major amount of cost is involved in the productions actually. Suppose renewable energy, if you take solar energy, let us take the cell production cost is very high. So if we involve in the humans actually, so taking the cell and then minute operation, all those things are involved actually. So that things can be minimized if you use the robotics. So here the robotics completely transform the traditional methods like grafting, cutting, drilling, polishing, everything can be replaced with the things. Traditional methods can be replaced. And if you see, already I told you that is manufacturing, assembling, installation, all these things can be utilized very well in the on-field also. That is the thing. So this robot will improve the quality and enhance the productivity of the renewable energy systems. So now, with that renewable system, we are mainly going to consider two sector here. One is solar energy sector, another one is wind energy sector, where we will use this robotics effectively. You will see that. Because a lot of classification are there, because due to time constraint, I have taken only the two major energy sector where now there is majority of the robotics are being involved in that actually applications. So let us see that first solar energy sector. So before starting that, some few solar energy, that is solar thermal equipments and solar PV, just a few introduction about this so that it will be very useful to where effectively it can use the robotics applications. Yeah, now first we are going to start with the solar energy sector. Mainly constantly power plants only we are going to use. These are the major power plant you will come across with respect to the solar power plant. This is like a constant nowadays solar thermal, that is solar thermal and solar PV is there. So PV will come later. This is solar thermal part. In the solar thermal part, the power plant will be based on the solar parabolic dish, and the second one, this is central tower. These two are meant for the high temperature production, and this is for solar parabolic trough and then funnel reflector. This is for the medium temperature application. If you see the power plant in any one of the this solar thermal equipment will be there. So what are the major advantage and disadvantage? Means it will be installed in a vast area actually, like in a desert areas, or it may be in the land areas. Some huge area it will be taken, because we are getting 1000 watt per meter square actually. So if you install more area, so more amount of energy we will get like that. So what will have, we cannot continuously monitor all these things. What is the operation, that is what is the performance with respect to efficiency. So there we will use this robotics. This is the if you take any power plant except PV, solar thermal means you will come across all this technology. Solar parabolic dish, or either central tower, or solar parabolic trough, or funnel reflectors. So this how this technology is not working, that is different actually. So here this technology I want to show some this few slides, one or two slides only. And then PV, now is solar thermal and then PV. PV means you mainly see only the photovoltaic panel. So this photovoltaic panel, you can see that what are this left side, it is existing in the outs nowadays, and nowadays there is concentrating photovoltaic is also booming actually. So now the applications, more applications are increasing actually, because concentrating means less number of that is lesser quantity of silicon cell will be used actually concentrating, and another sun rays will be concentrated. This is the technology involved in that. So even if you see this CPV plant, in a vast area it will be installed. In a huge, that is area occupied, that is area of the collector will be more actually. Even human cannot go on do it can. Now it is happening now in some places robotics are using, some places humans are cleaning actually, because cleaning is very important aspect in all these things. If dust is accumulated in this panel, or if any breakage, suppose if any breakages occurs in the reflectors, so we have to continuously monitor all these things. For this purpose, every time you cannot deploy the humans to go and inspect all those things. So such things are very important for this. So this is the introduction about the PV panel, and then concentrating photovoltaic. In the previous slide, we have the solar thermal, all those things. This power production, just I will show that this is the typical curve we will get in the PV plant. This is IV curve, current voltage curve. If you are not cleaning, that will come later actually, cleaning part. If you are not cleaning, if you are not inspecting properly, this curve will be deteriorated. This is the main objective of this thing. So we are mainly focusing on the power production side. So that is the thing. This is the typical IV curve for the PV panel. And this is the insulation. If more insulation comes, our power curve will be more. If less insulation comes, means our power production will be less. That is obviously, you know that this is current will be more. If more insulation means more solar radiation falls on that, we will get more power. If less solar radiation means less power we will get. That is the indications. This is the concentrating PV. I already told you CPV. The PV I already told you. PV means photovoltaic. CPV means concentrating photovoltaic. Wherever you see only this plan, this thing only, you are going to see all these things. Now let us see the coming to the robotics part now. Where that's it is important, it will be deployed. These are the three cells normally used: monocrystalline, polycrystalline. Anyhow, this is additional information I'm giving. If you see the cells, it is fabrication level. If you see, it consists of aluminum frame, glass, and ethyl vinyl acetate sheet actually will be there, and solar cells. After that only solar cells will be there, and again EVA sheet will be there, then back plate will be there, and then aluminum frame will be there. So all these things are involved in the minute assembly part actually. Okay, so these things are very, if you are not doing properly, it will affect the performance actually, ultimately. So now these are the things, technologies are available. No, I will not go into the technology. Just these are the things. I'm just to give glimpse about the solar PV and solar thermal. Now let us start the things. This robotics and solar energy sector, where it can be used mainly the handling cells and wafers, installing, assembling, and performing that is operation maintenance of solar panels. Whatever the solar panel is shown to you, if this anything happens, if suppose shadow falls on that, if bird droppings are there, if dust is there, if more accumulated, this performance will deteriorate. So we have to continuously monitor all these things. This robotics can be deployed properly. You can see it here. Suppose if it is in the inclined manner, automatically the dust will accumulate in the edge of the solar panel. We see here. Sometimes it will be in the slightly inclination is very less. Say for example, if you take our place Karakal, the latitude is 10 degrees. So if you see 10 degrees, the inclination is very less actually. So dust accumulation will not come to the edge actually. For that, proper cleaning is required. That too, huge land area means you cannot deploy the human being every time to clean the things. For that, you can utilize the robotics to cleaning the solar panels. And also assembling, I said, this is the assembling of the solar panel, that is glass, aluminum frame, glass, and the EVA sheet and solar cells. Then after the EVA sheet, all those things are assembled manner. That thing, minute particles, minute sections can be assembled by using robotics. You can see it here. What type of, if you use robotics, what will happen? This efficiency has been improved. Almost some 1 to 2% improved in the cells actually. You see that cell efficiency, now typical efficiency, if you see in the practical efficiency is some 18 to 20%. But in the laboratory scale, it is 24, 23 something. But if you use the robotics in the cell fabrication side and assembling side, the efficiency of the cells will increase from 23.2, this is the recorded efficiency, 22.78% to 23.45. So this silicon wafers and then cutting of the wafers, it's a micron size actually. So cutting of the wafers, all those things will be taking place by using the robots actually. But if you suppose if you include the robots, the efficiency will be improved actually in the manufacturing side. And normally this IRB flex picker ABB based robot that is used for the sorting and starting and then handling the delicate components of the solar cell. So this is the cell it is used actually. IRB flex picker ABB solar. I will show the figure. So it is also used for loading and unloading of the solar cells in the fabrication side. Things. So this information, if you see about that robots, it is maximum handling 15 gram at 200 cycles per second, and its payload capacity is 145 up to maximum of 8 kg. If you see that robots here, just you can see it here, the IRB 360, which is used for the solar cell wafering handling sections, and also for unloading and loading of cells. This is the thing. And another robotic, that is IR 4600, it is used for that is pelletizing and then depolarizing the solar cells, that is in that solar cell manufacturing. This can be used in the operation sector. Again, this is also used for loading and unloading application also. And another solar cell, because this is for soldering in the PV cell. If you see, ribbon kind of white color material will be there actually. This should be soldered perfect. This will be by using soldering. This should be the above and below the solar cells actually. So this type of intricate things can be done by using IRB 1600 robot. So this can be rotated in. I think degrees of freedom is 4 to 6. You can see that almost this for ribbons and soldering of solar cell modules, making all this thing, it will be utilized actually. And apart from that, if any breakage occurs, say for example, in the PV panel, if any glass breakage occurs, what will happen? That will be exposed to the ambient continuously. After that, some dust accumulation will be more in that. So for that, where it is broke, all those things should be need to be identified and be checked in. And then in the level of manufacturing of solar cells, without any breakage level also, this should be fabricated actually. If cells are very micron thickness, so this can be monitored by using a overhead mount robot actually, CS650. This is another type of things involved in the solar sectors. And also apart from that, if huge, that is, if the size of the panel is in more, then in this case, in one robotic institute, that robotic institute of Shanghai, they have fabricated the robotic platform. Automatically, it will handle the large size of solar arrays actually. So such things are also available here. So if the PV panel normal size is 1.5 meter by 1, that is 1 meter. If the size is increased, then accordingly that robotic also involved in that fabrication. So there is the large size solar handled robots actually. These are things also available. It will take us everything, because cutting, that is cutting of wafers and then assembling all those things. And let us come to the dust. Dust is very important things. We need to be taken care very properly. Otherwise, your efficiency of the PV panel deteriorate actually. That is the things. So normally in the PV panel, the first topmost thing is the transparent glass will be there actually. So that will allow the solar radiation. After that, anti-reflection layer will be there, anti-reflective coating, all those things. But here the glass, we have to clean it properly. If it is not cleaned properly, so it will not allow the solar radiation to inside the PV panel. So it is for particular, a lot of research work also being carried out. They found that for different solar insolation, if the dust level is more, so the decrease in the power production also will be more actually, like that they said. That means for more amount of solar radiation falling means this decrease in the efficiency will be less. At very lower insolation, lower solar radiation falls on that, this efficiency reduction in the PV panel will be more actually. That is the things. So this relationship is like that actually. if you see, if it's not cleaned properly, so the transmittance will be reduced actually when it is days exposed to more number of days. So that means cleaning of the panel is must. So for this cleaning, how we are going to do this cleaning? That is the thing. Sometimes rain will help us to clean the panel. In this, always you cannot expect the rain, and in desert regions, it will be sand accumulation will be more, and cleaning with you can see the power plant. It is in a huge area, almost 5 acre, 10 acres, like that. Also, PV plant will be there in a megawatt scale. So this need to be cleaned, monitored in a very clean manner, in a perfect manner. We need to clean this glass. Otherwise, the entire performance of the PV panel will be reduced. So such cases, the robotics are deployed. I told you. This depends on that is autonomous robots on board the sensor technology they used here. If you use this robot, the operational cost is minimized. That is the thing, recorded thing is there. If you use these robots, that instead of human, the robots can clean the glass surfaces. That will be very effective, and so that the cost is also minimized. This operation cost is minimized means automatically the power production cost also will be minimized. So this is the this is the wheel-based mobile robot where that roller, brush, and fan and blower fans will be there. So it will be operated on the PV panel. So it will clean the cells actually, clean the glass surfaces. That is the things. You can see it here. Based on the cleaned and non-cleaned, if you are cleaned means your efficiency will be more. That is ultimately power production will be more. If it is not cleaned means power production will be less. That you know very well. So this cleaning is must. If you deploy the robotics in the cleaning section, your cost, production cost also will be operation cost also will be minimized. At the same time, it will be give the reduction in the power production cost. So here one solar cell, one solar panel cleaning robotic, that is SPCRA is used actually with 4 degrees of freedom. They use, and then they found that the time taken is 18 seconds, and then clean head, the 24 heads they used actually. They used almost energy consumption is 46 milliampere ampere hour. You can see that which less energy consumption, we can clean the entire area of the robots actually. That is the things. Just a minute. This is another company, Geeko. It is by using water mechanism. They used water as the for cleaning mechanism, and then they cleaned the PV panels, and either in the rooftop or else in the land area also. And another things, by using dry mechanism, that is blower will be there, and then by using vacuum technology, that the sand everything will be collected actually. It is another robot, E4 Ecopia robot. So they used also in the cleaning process actually. And then another things, the solar cleaning robot, by using dry, it is Kikai actually. So it will be also used in the cleaning, but these are all dry manner. They will not use water actually. You can see that it will be used in on the PV panel itself, so that it will be operated, so that entire PV panel will be cleaned actually. Now you can see the further examples. So the more things you can see it very thing, and also the assembling also it will be used. PV panel assembling, and then assembling means after the once the PV panel is produced, that is fabricated in the site, on-site assembling, that is also done by using the robot actually. And also some drones also will be used to inspect the PV panel, whether any crack is there or any bird droppings is there anywhere, dust accumulation will be more, any breakage of the glass, or any cells come out, any installation is not properly done, that can be also done using drones. You can see it here. This is the thing where you can see the monitoring the solar power plant. Because installing is okay, but after them continuous maintenance is important. For that maintenance, the robotics play a major role in solar sector actually. Now another thing, it is a solar panels, that is 2 German companies jointly they found that Momo robots, this will be used for the that is cell PV productions only, all these things. So here this is equipped with PV panel and numerous cycle operations, repeated cycle operations. So it will be it will completely reduce our manufacturing cost actually. It will reduce the manufacturing because operation cost is minimized. It will reduce the manufacturing cost. Either both in terrain or different weather operation also will be used actually. Both inside the company, the fabrication level, and then outside on-site deployment of the PV panels and the rooftop, all those things can also be used here. Here, this another thing, KUKA systems. This is also the used in the PV panels for packaging, framing, testing, all those things will be used in the solar sectors. So it will be minimizing the cost, entire thing. That is the final objective is to minimizing the cost. And also, I already told you the ribbon. Ribbon will be there in the PV panel. That ribbon soldering also will be taken care by the SCARA robots. If you see that is the SCARA robot, it will at the edge points, it should be properly, the soldering should take place. Otherwise, the performance will be deteriorate like anything. So if even the human beings are doing, but if you deploy the robots, our fast mass productions and then accurate soldering, all those things will be taking place. For this purpose also, this SCARA robots will be used for ribbons and diodes installation. And sometimes the installation, that is construction of PV, not only that, in the on-site, there also will be used. I told you, the aliens automated busing for robots will be used here. And then tracking system. The tracking system is also another important thing. Suppose whatever the solar technology I shown in the previously, that is concentrating type. I said concentrating photovoltaic, concentrating solar power system. Concentrating means we need to track the sun continuously actually, from morning to evening. So in order to tracking the sun, we need a tracker, perfect tracker. If the tracking system is perfect, then our power production also will be good actually. Will be good. So in this case, if you use robotic, that is tracker based on the robotics, that will be helpful in the power productions. You can see that very accurate manner we can track the systems. Because by using this, we can power production will be increased. But static and without, you can see that in the tracking system, if you deploy the tracking robotic system, your power production will be either PV or in solar thermal, power production will be more. So here we can use this power, this robotics effectively in the tracking system as well as in the cleaning system, and then in the assembling and then in the manufacturing of the PV cells, minute particles, also that is cutting of the wafers and assembling of the wafers, assembling of the PV panel, all those things we can effectively use that. So this tracking also another role. So we have to track the sun from different orientation, from 0 degree to 90 degree, elevation and azimuth angle. These are the two angles are there. So in order to accurately, if you use this, it will accurately track the system, and then our power production will be more actually. That is the things. So this is the Cubotics, that is the automated tracking system, mobile robot. You can use it for the tracking system. So by using this, almost improvement is 17.2% improvement in the energy productions. For a fixed angle they are used actually. That is the thing. I already told you the different power plant. I said the power plant, one of the drawback is dust, either in a PV panel or in solar power plant, that is based on concentrating solar power plant. Here the reflectors will be there. Reflector means it has to track the sun. Concentrating, if I say, means so it has to track by we have to track the system. We have to track the sun actually by providing proper tracking arrangement. So now you can see left side is called solar trough, and the right side is called solar trough. You can reflectors are there. So this reflector should be, now I'm showing one single. If you see in the power plant, it will be in a huge area actually. So all these things we have to continuously monitor this. For that, unmanned aerial vehicles will be used actually to, that is for climbing robots, to clean the surfaces, to tube whether receiver is, because here the main component, one of the component receiver will be there. That receiver is after some time what will happen, it will be undergoing sagging. Whether where the sagging will be there, where any crack is there, where any leakage will be there, where any steam is, that is water is leaking, all those things will be there, where steam is coming, any leakage is there, all those things can be predicted actually in the solar power plants. So all those things will be used in the solar concentrating solar power plants. This is another power plant, a central power plant, that is central receiver. It is called as a central receiver power plant. This also I shown in the first slide. Here it is normally, this is deployed in the desert region, and then huge amount of that is heliostats will be there. Heliostat, that is the plane reflectors will be there on the land that will track that is are undergoing the tracking, so that it will reflect the solar radiations onto the tower, onto the receiver, which is kept at the top of the tower actually. So this is installed in the desert region actually. In the desert region where you have to clean the surface must, and then and the receiver side is very high temperature actually, where that tolerable high temperature robots will be used to inspect the surfaces of the receiver, whether any leaking is there, or any whether the process is going on properly, that inspection, all those things can be done here. Apart from that, the remote monitoring also can be done here with the help of the robotics. Once the robotics give the input, so this can be also be data transmission. It can be by use in the remote monitoring also we can be done actually. Whether which panel is power production is less, why it is there, whether any crack is there, or any dust accumulation is there, or any properly it is not assembled, all this thing we can monitor it. We can continuously monitor that. Remote monitoring of solar photovoltaic power plant. This also option is there. And then apart from that, in the constant solar plant, the thermographic sensor at higher altitudes. Higher altitudes also we can, the climbing robots we can use that at higher altitudes. We can use that for the constantly solar power plants, and then we can take the information, whether what is the how the receiver is placed, whether any receiver pipeline joints, any leakage problem is there or not. All those things we can determine, we can monitor it, but we are using unmanned aerial vehicle for different levels and different speed also it is there. Now with that, you can see the major areas where you can concentrate the robotics in the solar energy sector. Similarly, we'll go to the other sector, that is wind energy sector, where the robots in the wind energy sector will be used actually. You can see it here. The wind turbine. Wind turbine, it is normally it is used the wind with the power available in the wind, and then it is converted into the electricity actually. It will take the power available in the wind, and then it used to convert into the mechanical power into mechanical energy into electrical energy. That is the things that this horizontal wind turbine is there and vertical wind turbine is there. So all the things are installed. It's some particular height, and the wind blade is also. It's not very short. It's a longer thing. Wind almost 10 meter, sometimes 15 meters, 12 meters. Depends on the size of capacity of the wind turbine actually. So this is the another area where you can concentrate more in the robotics wind sector. So in that wind sector, before going to the robotics, I will give the assembly. This assembly part is also very, very important. So minute particles are also there. This is entire set is called nacelle houses. Nacelle houses means inside you can see the converting of low speed to high speed. Shaft, gearbox, everything will be there. So this part should be assembled properly, and sometimes drilling is also required in the nacelle part, in the nacelle houses drilling. So these drillings are very minute section where you have to assembling is very important. There you can deploy your robots, both onshore and then both offshore, and then and the land installed turbines. This if you install these robots, what will happen? Your again constructional and the operation cost also wind turbine will be minimized actually because of this advanced robotics technology. And then why these things where this will be used means the main key objective of the wind turbine is turbine control actually, to optimize the more amount of power actually. So there in the turbine control is mainly depends on the blade angle adjustment, turbine rotations, adjustment speed, and all those things. This every time we cannot deploy the human being to go, and then we can take care of the system monitoring all those things. For this purpose, we can deploy the degrees of freedom robotic manipulators to handle the wind turbine and towers. So here robotics you can see here apart from that in manufacturing parts also will be used, and also in the after installing the system, this can be also used. It is a wire-based. Now here I have shown this is a wire-based robot used in the offshore system. You can see here. So offshore means that it is installed in the thing offshore, and this is the land side actually. This is the ocean. You can see that. So it is very difficult to every time you can monitor all the things. So you can install the wire-driven robot in the working of the offshore to monitor the surface quality, all those things. So this inspection detects the damage due to the bonding effects, air inclusion, delamination, all those things will be detected actually. Sometimes this wind turbine blades also should be inspected continuously, whether any damage, that is um, delamination is coming or not from the wind turbine, or any dust accumulation is there or not, that we have to monitor. So otherwise, this will be every time inspection blade through traditional methods. It is time consuming and then dangerous also, because some of the things in the offshore also will be difficult. So such similar to our solar PV sector, what robots will do, the same thing you can use it here for the monitoring purpose. And you can see this is how the wind turbines pipeline, that is center support, is installed. So General Electric presented a track based remote control robot that climb up to 300 feet. That is also used in our wind turbine actually. But it uses the onboard vacuum pump, and then it will remove the air between the machine and the turbine, so that it will be easily, it will be perfectly, it will hold the things actually. There we can use for the installation of the wind turbines. The robots can be used for installation wind turbine, and in the offshore, some, that is a few robot climbing G robots can also be used to inspect the turbine blades. Whether how it is after it is continuously exposed to the salt environment, what is happening in the blade surface, all those things can be monitored. Apart from that, we can do the micro and the macro inspection also. So inside the blade, on the surface of the blade, step by step also we can go, and in the over the entire area also can be monitored. In the micro and macro inspection by using robots. So if you use these robots, they have the comparison actually, cleaning the wind turbines blades manually, how if you do, what will happening, and if you use robotic, you will see that within half an hour to 45 minutes, 40 minutes, this can be completed cleaning per turbine, and the water consumption is also very low, and it's very safe. Okay, so these are the things where areas you can concentrate in that to minimize the cost of the robotics. We are using the cutting edge technology, and then if you minimize the cost, operation cost, automatically the power production costs also will be minimized. That is the thing. So this is another cleaning robot where they will use in the wind turbine section. For repairing the blade, sometimes the blades got repaired, or it will be stuck, or some birds will be stuck inside the things. So sometimes this should be need to be cleaned, all those things. For that purpose, this type of robots will be used actually. So here, most of the applications in the wind energy sector are only the fabrication, the operations. This fabrication involves blade manufacturing, drilling, and assembling, alignment with the things, and then sanding and painting. Painting also, it is another thing. For huge size of the blade, for long size of the blade, you cannot keep on deploy the humans for painting. So painting of the towers, painting of the nacelles, automation, material flows, installation, and applying blade coatings, all those things in the operations also, maintenance of the turbines, all those things can be, these are the areas of the wind turbine where you can deploy the robotics, these things. So now in general, we can see that this is the renewable energy sector where we have taken the solar energy sector and the wind energy sector, where we can concentrate more on the performance enhancement process. If you deploy the that is robotics, now they are majorly they are using in the solar and wind. If you concentrate more on that to minimize the cost of the operation cost, automatically your production cost also will be minimized. So by using the incorporating the robotics automation based, these things can be addressed properly, cost, so that we can generate the high volume, high yield, and a quick specification adaptability through inspections. All those things can be improved. So these are about the solar and the wind based these things, robotics. Um, if you have any questions, you can ask me, please. I will show you the another our research aspect. If you are interested, I will show that research aspects. Ashok? Yeah.
Thank you, sir.
Yeah. Thank you.
Thank you so much. And it's time to participants to ask any queries. Participants, please respond. Kindly unmute yourself and ask your queries.
Dear participants, you can unmute yourself and ask any queries if you have.
Sir, good morning, sir.
Yeah, good morning.
Yes, sir. Sir, can you please throw light on the UAV-based inspection of solar panels? Like, if you have got any idea of what is the time it can continuously inspect without further recharge? Like that, battery power is a big constraint in unmanned aerial vehicles.
Okay. No, normally when you deploy the robotics, the power consumed will be the PV panel. Normally, it will be used actually. Suppose.
Mhm.
Suppose if you use an unmanned aerial thing, the power consumption, if you see here, timing, how long it is in the milliampere hours only I have shown actually.
Yeah, yeah. No, my question was like this, sir. I couldn't probably put properly. I'm repeating it again, sir.
Yes.
So, like we use, if we want to use UAVs for
Okay.
inspection of the plants, means how much time continuously we can use it without further recharge, like roughly. Any reported documents, any in the literature, etc. regarding this?
No, it depends on how many number of cycles you are using. Say, for example, depends on the area also actually. What is the power plant area? Say, for example, like let us take 10 meter square is your power plant. So you have to use, I will show the data. You see it here. Yeah, minimum that is 5 to in the seconds we can complete that actually. Some 15 to 20 minutes for the entire land area. Some 2 hours per cycle I'm telling. Here I will
Okay,
show
okay.
you. So time consumed depends on the level of the cleaning and inspection also. You are asking a inspection only, no?
Yeah, I'm asking for inspection only, sir.
Yes.
Yeah, somewhere I came across during your presentation one of the slides, lithium ion batteries for some 3 hour recharge. It
It
will
is
do
the
1.5 like it was there in one of the
no. It
slides.
is the time is almost 18 seconds.
Yeah,
This is for
18
one-time
seconds,
cleaning.
something.
Uh,
It is okay. Fine blades, okay. Hmm.
yeah, I will show you.
Means just I'm working that related area, so that's why that question found felt that probably it is you can give some idea at least.
No, actually, we are not completely working on the we are working on the energy sector only. But if based on the literature review, what we are come across, it will be taking the some 10 to 15 minutes within we can complete the 10 meter square area. That is the thing.
Okay. I understood, sir. Okay. Thank you, sir. Thank you.
Thank you.
Thank you.
Our humble request to all the participants, kindly open your webcam.
Okay, Ashok.
Dear participants, kindly open your webcam. If you have any queries, you can ask the expert. Thank you, sir,
Thank you.
being with us and for your expert delivery.
Thank you. Thank you so
Thanks
much.
for-
Thank you.
And thank you all the participants. Kindly attend the session at 11 o'clock, 11:30. Until then, stay with us.
Hello.
Yes, sir. Hello.
Question. Can I ask question, sir?
Yeah. Please, sir.
Sir, I have only one small thing I want to know.
Yes,
In
sir.
energy, any problem is happened, I think. How you troubleshoot that problem?
Which system you are talking about, sir? Energy system means?
Even in the solar or your wind, you are telling no, so
Okay.
many things.
Yes, sir.
Suppose if it is having any problems or anything, how you resolve that problem?
Yeah, let us take solar PV actually. Okay.
Yeah.
Solar PV, now the major problem is dust accumulation, sir. First thing. Either if the dust are more, if you accumulate more amount of dust on the surface of the transparent glass, it will affect the solar radiation enter into the PV panel actually. So for that purpose, cleaning is must. How we are addressing the cleaning means different traditional technologies are also available. One is through water-based cleaning, and other one is robotic based cleaning actually. So robotic based, when they will deploy robotic based means for huge area, if one or two panels means it will be very easily we can clean ourselves. If it is for deployed the PV panels in the almost 10 acres or more number of PV panels, so in a megawatt power plant, we cannot go and inspect the each and every PV panel. So for such cases, we can deploy the robotics sensor, and then we can clean the surfaces, either in wet based or dry based. That is the things. So another, this is the first troubleshooting. This is the first problem, and second problem is if it is not inclined, if it is not installed properly, it will show in our efficiency only. So we can easily predict why this efficiency is very less. We have to analyze that. All this. So if you analyze that PV panel, we will come to know whether it is properly installed or not, whether any dust accumulation is there or not, whether cells are properly placed or not. All the things we can see that. Sometimes cell damage also sometimes lead to poor performance.
Another thing is that the robot can see the sensors or anything is there, exactly can find out, identify the problem very easily, or it is difficult?
It will easily sense the dust, but here so far we are used for dust only, sir. Actually, dust particles only to remove the dust particles. If other than any major obstacles will be, you mean to say like that, sir? If any obstacles, suppose some stone is there, that whether it will predict or not, that is your question, or I'm correct, no, sir? Whether I understood properly?
Yes, yes. In a wind pan, suppose the wind pan is there,
Okay.
it will be
Yes.
there wherein high. You will be rotors will be there. Rotors will be should work properly, and also
Yes, sir.
inside that magnetic and yeah.
That's why for that power
If suppose
monitoring
such
system
things is
will.
goes wrong,
Okay, sir.
yeah,
Whether how the robotics will play a major role.
yeah. You know
That we
how
have
it
to
will when
monitor.
problems comes, yeah.
Yeah, that will be my remote monitoring
Tell me,
also
sir.
we can be done. Yeah, remote monitoring also can be done. Here we can take the information by using robots, and then it will be in the software side we can easily analyze where the problem will be there and where it is, because easily it will be connected to suppose in particular zone it will be where this problem means when only the particular one can be checked actually. Like that we can troubleshooting can be done in that. you can no need to inspect the entire thing. With the robotic informations, we can also analyze in this area. This will be the problem. Will be there like that. Say for example, major things means only the surface dust. Yes, sir. Okay. Okay, sir.
Okay, sir. Thank you. Thank you
Okay,
very much
thank you,
for
thank
your
you.
nice lecture, sir.
Yeah, thank you, sir. Thank you so much.
Thank you so much, sir.